In this part of the unit current electricity, you will learn about series and parallel combination of resistors. Series and parallel combination of resistors. You might have seen in our houses, different appliances are connected in parallel combination. From main line, two wires enter in our houses. One is live wire, other is neutral wire. Live wire passes through main fuse, then it passes through electricity meter, and then it passes through main switch, and from main switch these two wires, live and neutral, pass through different appliances connected in parallel combination. All these appliances are also connected with the earthing system of the house. During Deepavali celebration, you might have seen we decorate our houses with lightings. These lightings are connected in series combination. These are connected in series combination. Let us understand in detail these series and parallel combinations of resistors. Firstly, we will study series combination. So, three resistors having resistances R1, R2 and R3 are connected across the terminals of the cell having terminal potential difference V, and their resistances are R1, R2 and R3, and a common current I is flowing through all these resistors. I current is passing through them, but the potential difference across each resistor is different. Across R1 it is V1, across R2 it is V2, and across R3 it is V3. So in series combination of resistors, we have seen there is same current flowing through each resistor. Same current is flowing through each resistor. The amount of current flowing through each resistor will be same, but the potential differences across different resistors will be different. And if we add up all these potential differences across different resistors, we will get the potential difference equal to the terminal potential difference of the cell. So V is equal to V1 plus V2 plus V3. By making use of Ohm's law, we can write V is equal to IR, V1 is equal to IR1, V2 is equal to IR2, and V3 is equal to IR3. So this I factor is common in all the terms, so it will be cancelled out. So we will get R is equal to R1 plus R2 plus R3 as the expression for equivalent resistance of three resistors connected in series combination. R1, R2, R3 are their resistances. Now we will see parallel combination of resistors. In the diagram, three resistors having resistances R1, R2 and R3 are connected in parallel across the terminals of the cell having terminal potential difference V. So you can see I current is flowing, is drawn from this cell, and it is divided in three parts. I1 current is flowing through resistance R1, I2 through resistance R2, and I3 through resistance R3. You can see all the three resistors are connected individually with the terminals of this cell having terminal potential difference V. So across each resistor potential difference will be V. That is the potential difference across the terminals of the cell. So once again we will understand this concept that in parallel combination of resistors, current flowing through each branch is different, but the potential drop across each resistor is same. Why potential difference across each resistor is same? Because each resistor is connected individually with the terminals of the cell. That's why potential difference will be same. So I is equal to I1 plus I2 plus I3. Putting up the values of I, I1, I2 and I3 by making use of Ohm's law, we get I replaced by V by R, I1 replaced by V by R1, I2 replaced by V by R2, and I3 replaced by V by R3. Now this factor V is common in all the terms, so it will be cancelled out. We will get as a result 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the expression for equivalent resistance. Now we will try to understand this concept of series and parallel combination by this example. 10 resistors are connected in series and parallel combination in a mixed way. we have to find the equivalent resistance of this combination. R equivalent, what will be its value, that we have to find. So we will start from end of this diagram. There are two resistors having resistances 3 ohm and 7 ohm. R7 is 3 ohm and R10 is 7 ohm. These two resistors are connected in series. Why these are connected in series? Because same electrons are passing through both the resistors. Current flowing through both the resistors is same. So in series combination their equivalent resistance will be 10 ohm. Now this 10 ohm and this R8 is equal to 10 ohm, both are in parallel. Both are in parallel. What will be their equivalent resistance? 1 by R is equal to 1 by 10 plus 1 by 10. So that will be 2 by 10 is equal to 1 by 5, or R equivalent is equal to 5 ohm. So up to this R8, the equivalent resistance of the combination is 5 ohm. Now this 5 ohm and this R9 resistance, that is equal to 5 ohm, are in series again. So equivalent resistance will be 5 ohm plus 5 ohm is equal to 10 ohm. Now this 10 ohm and this R6 resistance, which is equal to 10 ohm, are in parallel again. So their equivalent resistance will be 5 ohm. Up to this point R6 we are having 5 ohm resistance. Now this 5 ohm and R5 5 ohm both are in series. So their equivalent resistance will be again 10 ohm. This is 10 ohm. Now this 10 ohm and this R4 is equal to 10 ohm, both are in parallel. So their equivalent resistance will be 5 ohm. Again the same formula you will use, 1 by R1 plus 1 by R2. This 5 ohm and this R3 is equal to 5 ohm. Both are again in series. So their equivalent resistance will be 10 ohm again. Now this 10 ohm and R2 10 ohm both are in parallel. So their equivalent resistance will be 5 ohm again. 1 by 10 plus 1 by 10, 5 ohm. Now this 5 ohm and R1 is equal to 6 ohm are in series. So their equivalent resistance will be 11 ohm. So equivalent resistance of this circuit is 11 ohm. Once again we will try to understand this concept. These two are in series, that is parallel in with this, and these are in series, then this is parallel, this is series, then this is parallel, and this is in series with this, and this is in parallel with this. Finally this all is in series with this 6 ohm. So we get 11 ohm resistance as an equivalent resistance of this combination. Now advantages of parallel combination of resistances. What are the advantages? First advantage is that in parallel combination, failure of one component does not affect the failure of other components. If our one appliance gets defected or error comes in its functioning, other appliances will not be affected by this parallel combination. And the second point of importance is that every unit that is connected in a parallel circuit gets equal amount of voltage and it draws current as per its requirement. That's why household appliances are connected in parallel combination. What are the drawbacks of series combination? If one point breaks in series circuit, the total circuit will break. So one fault affects the functioning of all the devices. This is all about series and parallel combination of resistors. Thank you.